Igama lami nguMelusi kaSkhosana. Sothi sibale ama-radians ukwenza nje izibonelo zama-radians siwabale ubude nama-length nakho
In
konke
the
lokho kuthiwa
circle
yi-isoclid
below,
below central,
central
and then
angle
GOH has a measurement of
GOH. So
3.2
central
radians.
angle
What is the
GOH
length
has a
of
measure
G
of 3 halves
GH or
radians.
arc
What
GH?
is the length
Kuthiwa
of
i-arc
arc
GH ubani lapho
GH? So let's
i-measurement
define some variables that'll help
ka-GOH
us manipulate them a little bit
siyambona
easier. So where is
u-GOH laphayana
central angle
u-3 over
GOH? This
2.
GOH, it's
Kuthiwa
this
kasithi
angle right
i-angle
over
yethu
here. Let's call that
angle
theta.
yethu leyo
So let's
soyisebenzisa
say that theta
so
is equal to the
measure
measure
measurement yethu
of
ka-GH
GOH, of angle
leyana ngibonise yena theta
GOH.
wethu.
Now, they're asking us what's the
GH
length
ubani?
of
Asithi
GH,
mhlambe
arc GH. Well, arc GH
simsebenzisa sithi
is
u-GH
this
wethu
right over here.
arc GH
And let's
yethu
call
leyana
that S. So let's let S be equal to the length of arc GH. And they also give us the radius is 6 centimeters for this circle, but let's just call that R for now. So the radius is equal to 6 centimeters. So the first thing that we should think about when we're dealing with arc lengths and radians is how do angles measured in radians relate to arc length? In particular, how does an angle measured in radians relate to the length of the arc that subtends that angle? And in this case, the length, this arc right over here, arc GH, subtends angle theta, subtends central angle GOH. So what's the relationship? Well, the definition of radian measure says that an angle measured in radians is the ratio between the length of arc that subtends that angle, so S, and the radius of the circle, and the radius of the circle. If this was a unit circle, then it would just literally be equal to that arc length. If it's not a unit circle, or I guess in all cases, unit circle or not, it's the ratio between the length of the arc that subtends the angle and the radius. Now, given this definition really of what a radian is, let's see what we know and what we don't know. And we can manipulate this however we see fit. We could multiply, you could see this written as if you multiply both sides of this by r, if you multiply both sides of this by r, you get r theta is equal to S, or another way of writing it is you could get S is equal to R times theta. S is equal to R, S is equal to R theta. And we could have solved this equation or this equation, but for this problem, this one's actually going to be a little bit useful because this is the unknown, the length of GH. We want to know. We want to know what this is. This is the unknown that they're asking for. And this explicitly solves for the unknown. So it's essentially solved it for us. So what else do we know? Well, we know the radius. We know the radius is 6 centimeters. We multiply that times the angle in radians, which is 3 halves radians. And we are left with, so S is equal to 6 centimeters times 3 halves. And so we are left with, this is going to be equal to 6 times 3 is 18 divided by 2 is 9. It's going to be equal to 9 centimeters. And we are done.